First of all, thanks a lot for this award. We're very humbled by this decision. Really super happy that the Scrum community awarded this award to our paper. So who are we? So basically, the paper was first PhD paper by Stephen Thomas, also called Steve. He was supervised by Ahmed and Dorothea, and I was postdoc back in the day at Ahmed's lab. So that's how the four of us got together there. And now 10 years later, we're all still at Queen's. So Ahmed and Dorothea are still with the School of Computing. Steve is now director of the Masters in Management, Analytics and AI at the School of Business here at Queen's. And since July 1st, I'm also back at Queen's as Associate Prof in School of Computing. All right, so since this is Scrum, let's start with a controversial question. And this question is basically the first question I thought of after like the initial emotions of getting the award settled down. And it's basically the question like, what was the paper about again? Now, before there's any uproar and you guys start complaining and maybe ask back the award, I can assure you, please bear with me. And by the end of this talk, this question, where it comes from, what its implications are, will become clear. So please let me explain. So for that, let's go back. Let's go back to January 2010. Back then, Ahmed and I, we've been working on a couple of things, and one thing in particular then in our minds was separation of concerns in software engineering. So basically, you have developers, they have certain things in their minds, requirements, functional, non-functional ones, and all of these things, they have to be implemented at some point in the code. And then an ideal code base should be easy to recover and know where each of these concerns is implemented. So every module has one concern, so it's nicely marked, interesting. To understand the code is easy, to maintain it, and so on. But of course, probably you guessed already that in practice, the ideal code base does not really exist. And there's problems of what's called concerns being scattered across multiple modules, and in those modules being tangled, being mixed up with other concerns, making it hard to maintain, understand, and so on. So that's why people had been working a lot on techniques, aspect mining techniques, concern mining techniques, that given a certain code base are able to kind of recover the different concerns, where they were implemented, and so on. And at that point, we also had been working on something that used the version control history, and I would be published actually later in 2010. In parallel, you had Dorothea and Steve, and they were in the kind of parallel domain, basically kind of information retrieval in textual documents, be it like newspaper, medical documents, music document, like any kind of doc. And the idea is there that those documents, they talk about topics that the authors of the documents wanted to kind of talk about. And then ideally, and you might recognize this slide already, you have documents, and each one has like ideally one topic per document, so it's easy to figure out, okay, what should I read to know about this topic, and so on. And of course, you might guess the next slide as well, is that, in reality it's not like this. Topics are also scattered across documents, they are mixed up with other topics, ending up with something like this. And again, you need some techniques to kind of go back from this tangled and mixed representation of documents to like the individual topics. And then we have, for that, you actually have techniques called topic mining, topic modeling techniques. By the way, this is an actual slide from back in 2010. And the idea is that those techniques have some parameters. They consider document as bags of words. And then techniques like LDA, LSI, and so on, they are able to kind of separate, recover sets of words that are the topics. Plus all the words in the topics, they know what percentage of it contributes to each topic. And then for each document, they know what percentage of each topic is in that document. So we had these two parallel lines of work, and it was really fascinating because we both recognized the other person's kind of similarity to our own kind of concern or topic. So we really started like discussing during breaks, during lunch, like really it was fascinating. Like from my side, okay, would topic mining be the ideal kind of concern mining technique? From Steve's side, well, what about this concern mining? Would it also help us with topic mining? So, and we kind of got to this understanding, this assumption, hey, concern and topic is actually probably the same thing. And we were not alone. There were already people actually who suggested that, like Kuhn et al., Baldi et al., they use topic mining for aspect or concern mining. And the basic idea there is that you have the source code and you just interpret as documents, and then you can apply topic modeling on that. So that was kind of like our state of mind back then. So on to the paper. So Steve, I joined in January 2010, and we got to planning that his focus of the CSD would really be like this evolution of topics. So look at how across time you would apply topic mining, and you get these bags of words, sets of topics basically across time there, and then basically you like this, and then basically you kind of try to link different topics to each other, and all this you would do because we would like to use this as a measure of how concerns evolve across time. For example, are certain concerns becoming more prominent in the code base, less prominent, or they at some point being split up in different topics like that maybe work together? So that was kind of the focus of everything. And we started working on this paper called Studying the Evolution of Software Concerns. So the word concern was really prominent in this paper. So evolution of software concerns, concern drift. We talked about an approach to measure and analyze the evolution of concerns within the software system. And to do that, well, we had this subject system we looked at, JHodRO, which might no longer be that known, but back in the day it was the subject system for like aspect mining and concern mining. We looked at 12 versions of it, used mallet for topics. I'll explain later what technique we used to do the history of topics. And basically we had a couple of research questions, and the first one was really about a bunch of metrics, like two existing ones, a new one, that we kind of measured on each concern in each release, such that we then could have plots per concern, in which for a given concern you could see how those metrics evolve across releases. So we had the assignment of concerns, so which basically mean the total topic weight, so how prominent the topic was across the files in that snapshot of the code. Scatter, which was basically how spread out basically is the implementation of a topic / concern across the files. And then our own metric focus, which was more okay for those files in which a concern / topic appears, in how many of those files is really the dominant topic basically. So we had these things and we looked at the trends of them, and then in the second question we kind of sampled 4, and as a kind of demonstration, let's say, of the approach, we kind of interpreted like big peaks and drops in the evolution of those metrics. And finally we also had something about co-evolution of concerns, where basically if a certain two concerns had a peak in, say, the assignment of a topic at the same time, and also drops, we would consider them to be co-evolving. So these kind of topics were actually interacting with each other, and that those could be interesting to document and so on. So we worked on all this, and then we submitted a paper to ICPC. Surprise, yes, so because ICPC's deadline was more convenient and so on. So we submitted it, and unfortunately we got rejection. Was not accepted. Now the reason I'm showing this rejection, not to make fun or something of ICPC, no, it's actually quite the opposite, because we got really great feedback from the reviewers. It went from things like, okay, you only look at one system, it was actually the motivation of this concern evolution, to like kind of, well, that's this one metric, it's this focus metric is actually quite correlated with the other ones, is really useful. And so there was quite some things in there. But the most essential feedback we got, and it really helped us the most, was this one. It was really nicely formulated, and somehow it came as a shock / surprise to us, because as explained, we were in this kind of topics, concern, same thing, we want to focus concern mining up. And here we have this review saying, selling it as concerns does not make it stronger, but rather weaker. Just stay true to what you're really doing. And I was like, yeah, well, at first a bit of a bummer, let's say, but then we was like, yeah, what are we really doing? So going back to this slide where the topic evolution was focus of PhD of Steve, if you check what are we really doing, then actually we are looking at code changes on the one hand, and topic changes on the other hand, and the interaction between those. So the word concern does not actually pop up here at all. We're really looking at, does the evolution of topics reflect the evolution of the code? And with that in mind, we actually totally changed the paper, different title, validating the use of topic models for software evolution. So evolution of software, no more concerns. Topic models, and also the actual goal, it was like kind of really a first step towards determining the suitability of topic models in the analysis of software evolution. So really an exploratory study to understand, like, does it work or not? Like, what are the consequences? In fact, you went deeper, and even it's not just any kind of code change versus topic change, but actually we distinguished between bug fixes and refactoring and new features. And the idea was, is it really those kind of things that are correlated with change in topics, or is it more noise in the topic models themselves? So they're kind of useless. And that was kind of the goal. And we kind of reused, let's say, the first two research questions we had before. We ditched the co-evolution one, and instead we actually went deeper into the evaluation of change events, and we defined change events as being those peaks and drops in a metric that were really above a certain threshold. So these are really relevant, like very clear evolutions in the topics. If they would not match to something in the code, something was wrong. So, and for those cases, we sampled 80 of them, and then looked at change logs, release notes, and so on. And we got very good finding, because actually more than 90% of those events really agreed with what happened in the code. For example, a test suite was added, XML API was added, and so on. So really topics were like a very good indication of what actually happened in the source code. And now for real, we sent it to SCAM 2010, and it got in. So super happy, super stoked, and actually the reviews there as well were also very positive, and actually acknowledged that this is first qualitative exploration in this kind of thing. It's useful as an exploratory study. Sure, there were some downsides. There was still one system we looked at. The quantitative part was not that deep, but valuable, and actually could be future work. So that was quite positive, so we were happy, and went to Romania 2010 for SCAM and XV. And well, here's a picture of the entrance of the building where the conferences were. Here's some impressions of the conference. Here's by me actually asking if ice cream was really available and free during the breaks, and it was true actually, and so on. There was even a soccer game where Steve showed his the skills he always showed every week in our own soccer games. And here you might actually recognize probably the general chair of SCAM 2020 before being tackled by one of my co-authors. I don't have the picture from after the tackle. We should ask him. Okay, so very cool, so lots of fun. We also, of course, discussed the work and got interesting feedback, and we had our list of future work for that paper, and the first one obviously was like, generalization. We only looked at one system, so we want to look at more than one system, and that was actually the SCP journal extension. So basically, here's this paper, and what we did, we actually also considered JEdit, and apart from JHodro, and for both, we actually looked at more change events, so more validation of actually what, if there's a correlation between topic evolution and code evolution. And we got, again, ballpark, same number, 88% of the cases were actually correct. Also, we mapped it in more detail to, like, is it bug fixing, is it like adaptive changes, perfective changes, and there we did not find a fully consistent change or findings, but in both cases there was a reflection in the topics from what happened in the code. And that was good. And then we also had further classification of the topic assignment curves. So that was nice. So that kind of confirmed what we had found before. And then we went on to actually the things we were really looking forward to, kind of like, for example, the technique we had been using for the evolution of topics, which is called the HAL approach, turned out to be quite biased and not actually working well in the source code world. Why? Because how it works, you have, imagine 3 commits over time or 3 releases, and what it does, it actually does not look at the actual change that happened, but to the resulting file revision. So for example, if you add the orange file, it will look at the orange file as input. It does not immediately run LDA on this, it waits until the result of the second commit are in. So this is some green thing was added, some brown thing, but the orange part is still there mostly. And again, the orange part is still there after commit 3, the brown part. And then it just takes all of what we see here So the 3 orange part, the 2 brown parts, the 2 green ones, and the yellow part together, and that's the input for one run of LDA. That's how it works. And then after you get the topics, and then it kind of, using statistics, kind of matches the results back to individual snapshots. And it works. However, you might notice that the orange part really dominates the input, and the brown part as well, and that for the green and yellow changes, there's not much data actually. And why is it? Because, well, originally Holodoc was actually proposed for, say, newspapers and this kind of documents where every day everything is different. There's no repetition, so there's no orange part after the second commit anymore, so to speak. But here in source code it's different, because in source code, if you look at the changes, they are minor. So you have the initial change here, you had the orange file, but then you have a minor green change, a minor yellow change. Sure, you had then a brown thing, which is bigger. So instead, what Steve proposed is like his diff LDA approach that actually looks only at the diffs. So, and then it would look like this. You would still have orange and brown as the bigger kind of chunks, because they're bigger anyway, but the green and yellow now have more chance, more data, more proportion in the input, and so topics could also be found inside them. So that was the diff LDA approach in a nutshell. And in the MSR 2011 paper there, an evaluation was done that found, yes, if it's more fine-grained, you find more distinct topics than before. They were not like combined anymore or dominated by the other topics. Plus the change event, you found more change event that actually matched with individual events in the source code. Furthermore, we also, apart from doing similar analysis before with like those change events and matching them with code documents and change logs, here we also did some simulated analysis where we actually generated source code changes and then checked if it reflected in the topic evolution. And finally, we kind of went on to like other things, like other kind of really applications, I think, of the technique, where really I think we really wanted to get to. That was like the goal of the research. For example, defect models, again, they benefit from topic information. There was a chapter on how to do topic analysis over time. In the MSR world, there was actually test case prioritization using topics, a study of Stack Overflow. So a lot of things, application were really kind of probably the initial goal of the work. And eventually, of course, the inevitable happens that Steve graduates as well. So that's that. That's, I say, our personal story there. But now what to make from all this? I mean, why did this paper get the most influential paper award? What actually happened? So we looked at the papers who cited either the SCAM or the journal extension paper. And we looked at a couple of things. First of all, we looked at, well, across time, how many citations are there? What happened? So turns out it's kind of like a normal distribution in multiple senses of the word, with especially a peak 2015 and then slowly decrease towards now. Could be interesting to discuss what happened there, but anyway, but that's how it looked like. And then we actually, and this excludes self-citation, by the way. And then we looked at, why did these papers actually cite us? What was the reason? So we looked at the place where they cite us, the context, and then tried to classify that. And there were like 13 reasons. And then there's like 3 slides. The first slide is a bit like miscellaneous reasons. For example, the word unknown. So there's quite some papers we either did not find online, either we found it, but it was in a language we did not understand, or the citation was there, but it was not actually mentioned in the text anywhere. Even not with these range citations, it did not. So yeah, those are not that interesting. There's some surveys that actually included the paper. Strangely enough, sometimes when people actually introduce LDA instead of citing Blay et al.'s paper, or sometimes in addition to citing Blay et al., they also cite our paper. So probably not really the goal of the paper, but then sure, Steve's later papers. Still some papers actually citing the paper when they say, oh, topics concerned is the same thing. Of course, these were our own papers, so maybe we're biased a bit. And then, okay, also some papers saying, actually you need, the developers of the system should analyze and interpret these topics, not the authors of the paper. So that was another interesting read there. Now, this slide is actually like some other kind of types of citations that perhaps make more sense. So the first one is actually, papers that actually cited because they use the same or a subset of metrics as we do. or they reuse the same parameter values, say the number of topics and other hyperparameter values, or they use the same methodology and or tools like Mallet. They would cite the paper, and or they would reuse the same subject system, so JHODRO and JEdit. So that's interesting because this means that the paper actually allowed these papers to actually justify their approach and methodology. But the most important reasons why the paper was cited were these. The number one, and by the way, the paper could be in multiple categories, so that's why the numbers do not add up. Number one was actually, especially at the start of introduction, people saying LDI has been used for this and this and this and this and this in software engineering, and for each thing they actually cite 1 or 2 papers. So, so would those papers have been impossible to publish without our paper? No. Our paper just added some more confidence, I guess, for reviewers or for other readers that LDA actually makes sense in the software engineering context, and that those authors could continue actually proposing what they wanted to propose. So, okay, it's cool, but so maybe the second category is maybe more what we were after and hoping to find, is that papers who actually cite our paper because they explicitly say, hey, topic evolution reflects software evolution, and they cite our paper. And that's cool because this actually meant that then those authors could rely on us for that, and they could do their own techniques or applications, so without having to worry themselves, how do we convince people that this makes sense? So that was actually more what we hoped to find. And also there was a group of papers that actually then cite our paper because they wanted to improve on the topic evolution technique. For example, the Hall approach, there was another approach they motivated. Again, that was also nice to find. So this brings us now back to the controversial question. So what was that paper about again? Why that question, and what does it have to do with what we just talked about? We already mentioned a couple of times, but for us, and also for me, the paper was actually like an exploratory first stepping stone, like just something to get to something else. Like we wanted to do those new topic evolution techniques, those application defect prediction and so on. That's what we really wanted to do. But to get there, like first need to understand a bit technology that exists. Plus, somehow, you want somehow to motivate that this makes sense. That topic evolution actually reflects software evolution. Yeah, so we could actually cite that paper and then do not worry about motivation anymore, but just do whatever we wanted to do based on that. And second one, it was like exploratory study. Reading it again, actually, I wonder, would it be accepted if submitted this year? Or not necessarily just Cameroon, but to any conference, would it still be acceptable to today's standards? One system, one person coding the cases, the topics, no written agreement. So for all those reasons, was not like when somebody, you know what Steve worked on. This was not the first thing that came to my mind. However, it turns out that the reason we had in mind for this paper, use their motivation, then move on, actually was also what others actually were able to do. And that's a pleasant surprise that actually it turned out to be useful in that way for other people, either to motivate the assumption they had in their work, or even to justify the design choices in their studies, like their methodology. So that was actually very good, and I think that's why the award, the Most Influential Paper Award, was awarded to this work. It really helped others to move on, let's say. And of course, there's some other thing, because there's interesting lessons to be learned here for students. So basically, just do research because you want to understand something. We wanted to understand the interaction between concerns and topics. That was really, we really want to get to the bottom of that. And that was what drove us for this paper. And then, we failed miserably because turned out, forget concerns, forget about it, focus on topics. But still, it improved our understanding, and especially that rejection actually helped us understand things better, because getting the paper right, getting to full understanding, quote unquote, takes multiple time, multiple iterations, multiple rejects. And so rejection is actually an opportunity, not a punishment, or it really helps you move on and understand things better. And finally, for students, maybe the same comment as the ISBC reviewer made to us. What are we really doing? It makes sense to really think about and multiple times, like, are you on the right track, or really looking at the core of storyline here, the core essence of things, or are you kind of adding stuff on top that actually just is redundant? I think that's a very, very useful lesson learned there. And for researchers and also reviewers, a couple of things. This is an exploratory study. It's probably would not stand up to today's very strict review criteria. And the question is, maybe that's actually legitimate. Maybe we should have more of this kind of study, because they do allow people to get an initial understanding of some problem or some field, and then to me they build on it with more advanced applications without having to wait for the definitive user study that gives 100% confidence, yes, go ahead. So I think there is room for these exploratory studies, and we should find a way perhaps to make them coexist together with more deeper studies. And similarly, there's a lot of concerns about the review quality nowadays, and this paper again gives a good motivation that good reviews, honest, actionable reviews actually really help. They help the authors to better understand their work and their direction, and to get to really the paper, the message they had in mind. So I think that's super important to spend time and effort on these reviews. And finally, the same as for students from the ICPC reviewer, who we really thank here. Stay true to what you're really doing. As well as researchers, we sometimes add kind of complex things on top of certain study, but actually the core message might be blurred, either like often through our own passion. In our case, concerned, like, we really want to get to the bottom of that, but it kind of stood in the way of what we were actually doing. So I think that's interesting advice. So to conclude, basically, we started saying, okay, the focus was really studying topic evolution over time, initially as a measure, a proxy of concern evolution. But then we got this very useful feedback saying, what are we really doing? So we focused really, okay, topic evolution, does it reflect code evolution? And we found, yes, it does. And then we also found out that the paper was really used for the reason we already initially made it, basically kind of supporting, motivating the use of topic mining here in this field, and actually helping then to go more quickly to applications of that, or to justify even methodologies of research. So once again, thanks a lot for this award, really appreciate it. And now, of course, we are open for questions.